Every engine breathes thousands of gallons of air for every gallon of fuel it burns. Hidden inside that air are microscopic particles capable of slowly wearing your engine from the inside out. So why do air filters that look almost identical vary so much? And which one actually offers the best protection? Most drivers blame engine wear on old oil or high mileage. But one of the biggest long-term threats is something much smaller: airborne dust. Every time you drive on highways, gravel roads, construction zones, or dusty parking lots, your engine pulls in massive amounts of air carrying microscopic dirt, sand, soot, and pollen. If enough particles pass through the air filter, they act like tiny abrasives, slowly wearing piston rings, cylinder walls, turbocharger blades, and other precision components. The air filter has one difficult job: let the engine breathe while keeping contaminants out. Restrict airflow too much, and performance suffers. Allow too much airflow, and more dirt reaches the engine. That's why engineers evaluate more than airflow. They measure filtration efficiency, airflow restriction, dust holding capacity, and how well the filter seals inside the airbox. Looking at only one measurement gives an incomplete picture. So how are these filters actually tested? Walk into any parts store, and you'll find filters promising better airflow, superior filtration, or longer service life. How can they all claim to be the best? The answer is standardized testing. One of the most widely used procedures is ISO 5011, which evaluates filters using standardized test dust. Engineers measure filtration efficiency, airflow restriction, dust capacity, and how performance changes over time. One surprising finding is that a brand new filter isn't always at peak efficiency. As dust builds up, trapped particles can actually help capture even finer contaminants until airflow restriction eventually becomes excessive. That's why replacing a filter too early wastes service life, while replacing it too late reduces airflow. The correct replacement interval depends on driving conditions and the manufacturer's maintenance schedule. But even the best filter can't protect an engine if one critical component fails: the seal. Most people compare filter media: paper, synthetic, reusable, or high flow. But another component often matters just as much: the seal. Think of a front door with a large gap around the frame. People would simply walk through the gap. Air behaves the same way, always taking the path of least resistance. A properly fitted seal forces all incoming air through the filter media. If the filter fits poorly, is installed incorrectly, or the sealing surface is damaged, unfiltered air can bypass the filter entirely and carry dust straight into the engine. That's why automakers engineer the airbox, seal, intake, ducting, and filter as one complete system. Aftermarket filters aren't automatically inferior. Many meet or exceed OEM specifications. But proper fitment is just as important as filtration. Even an excellent filter provides poor protection if it doesn't seal correctly. So if fitment matters, why do manufacturers use such different filter materials? Walk through any parts store, and you'll find paper, synthetic, nanofiber, and reusable oiled cotton filters. If one material were clearly superior, every manufacturer would already use it. The reason they don't is simple. Every material involves trade-offs. Traditional paper filters remain popular because they provide excellent filtration at a reasonable cost while fitting factory intake systems perfectly. Synthetic media improves durability, increases dust-holding capacity, and can reduce airflow restriction, making it common in heavy-duty applications. Reusable oiled cotton filters are popular with enthusiasts because they reduce restriction and can be cleaned instead of replaced. Critics argue some high-flow designs may capture fine dust less effectively, and that excessive oil during cleaning can contaminate mass airflow sensors. Manufacturers disagree when filters are maintained correctly, making this one of the longest-running debates in automotive maintenance. The key point is simple. No design maximizes airflow, filtration, durability, service life, and cost at the same time. Which leads to the biggest misconception. Does more airflow automatically mean a better filter? Imagine the perfect window screen. Smaller openings block more dust, but reduce airflow. Larger openings improve airflow, but allow more debris through. Air filters face the same compromise. Performance filters often reduce intake restriction, which can benefit modified or high-performance engines at full throttle. But for most daily-driven vehicles, factory intake systems already provide the airflow the engine needs. In normal driving, the difference is often much smaller than marketing suggests. In dusty environments, filtration becomes far more important than a small airflow gain. That's why there isn't one perfect filter for every driver. A commuter, an off-road vehicle, and a race car all have different priorities. So how do smart buyers choose? Choosing an air filter isn't about buying the most expensive one. It starts with proper fitment. Even the highest quality filter can't protect an engine if it doesn't seal correctly inside the airbox. Always use the correct part number and ensure the filter sits evenly before closing the airbox. Then consider how you drive. For most commuters, an OEM filter, or quality aftermarket equivalent, offers an excellent balance of airflow, filtration, durability, and cost. If you regularly drive in dusty environments, filtration efficiency becomes much more important. Performance vehicles may prioritize airflow under heavy engine loads. Finally, remember that every filter eventually becomes restricted as it traps dirt. Replace it according to your manufacturer's maintenance schedule, or sooner if you regularly drive in dusty conditions. The biggest surprise is that there isn't a universally best air filter. If there were, every automaker would already use the same design. Every filter represents a series of engineering compromises between airflow, filtration, durability, cost, and service life. That's why online debates never end. One driver may swear by a reusable high-flow filter, while another trusts OEM paper filters for maximum engine protection. Both experiences can be valid because they're based on different vehicles, environments, and priorities. The important lesson isn't that one type is always right. It's that understanding the engineering helps you make decisions based on facts, not marketing. The next time you replace your engine air filter, don't focus only on the logo. Think about what that filter actually does. Every time your engine runs, it breathes thousands of liters of air, carrying microscopic particles your eyes can't see. But your engine certainly can. Whether you choose an OEM filter, a premium aftermarket design, synthetic media, or a reusable performance filter, remember that every option balances airflow, filtration, durability, and service life. The smartest choice isn't necessarily the most expensive. It's the one that matches how you drive and provides the protection your engine needs. So before buying your next air filter, ask yourself one question. Do I need maximum airflow, maximum filtration, or the best balance of both? Once you understand that trade-off, you'll never look at an air filter the same way again. If you enjoyed this breakdown, tell us in the comments. Which air filter do you currently use, and has this changed how you'll shop for your next one? And if there's another automotive myth you'd like us to investigate, let us know below. Thanks for watching.